come with me if you want to live. That was a hard stretch. Okay. Okay, today we are going to be doing the fundamental counting principle. In this section, you will be able to find a number of possible outcomes in an experiment. There we go. Now, what is the fundamental counting principle? If there are X ways to choose a first item and Y ways to choose a second item after the first item has been chosen, then there are X times Y ways to choose all items. Now, if you don't quite get that, don't worry. You'll understand it after we start off by using a tree diagram. So over here, you pack 2 pairs of pants and 3 shirts for your weekend vacation. Create a tree diagram describing all of the outfits you can make if each outfit consists of a pair of pants and a shirt. So starting off, let's make it more realistic. We know we have pants and we know we have shirts. But let's tell which kind of pants. I'm not talking about designer pants though. I'm talking about the colors. So we have some blue pants and we have some black pants. Just something to make it more reasonable, more realistic. Shirts, we're going to say we have a red shirt, maybe your LJI shirt. You have a green shirt, probably like a Ninja Turtle shirt. Those are always cool. Everybody likes Ninja Turtle shirt. If you don't, you should have one. And you also have a yellow shirt. Yeah, not really sure about yellow shirts. But if you have one, that's cool. All right. Now we're going to make a tree diagram saying what outfits we can make with blue pants and black pants with all 3 of these shirts. So you can do blue pants with your red shirt. You can do your blue pants with your green shirt. And you can also do blue pants with your yellow shirt. Hey, X-Men is yellow, huh? You could do an X-Men shirt. There we go. So those are a couple of outfits that you can do with your blue pants. But don't forget about your black pants. So if you had black pants, you can wear your black pants with the red shirt. You can wear your black pants with your green shirt. And you can wear your black pants with your yellow shirt. Please excuse the handwriting, but this is what a tree diagram is. It shows the branches between each item. So you have these combinations, these outfits of blue pants, red shirt, blue pants, green shirt, blue pants, yellow shirt. You also have black pants, red shirt, black pants, green shirt, black pants, yellow shirt, which is a total of 6 outfits total. Total. I keep saying that. But 6 outfits. Now, I'm going to show you exactly what the fundamental counting principle is. Now, what they are saying, is that you have a spot for your pants. You have a spot for your shirts. Now, how many pairs of pants do you have to choose from? 2. How many shirts can you choose from? 3. And if you multiply those 2 numbers, you will have your total outcomes possible. 6 outfits. So going back, if there are X ways to choose the first item, which were our pants, in which we said there are 2 pairs of pants we had, and Y ways to choose a second item, which were our shirts, and we had 3 shirts to choose from. So you will do 2 times 3. And we had 6 total items. So that's what the fundamental counting principle is. So let's see if you can find all the possible passwords to this problem. All right, in this one, it tells you that you have 5 characters. So we know we're going to have 5 little boxes. 1, 2, 3, 4, and 5. And we know of those 5 character boxes, 2 of them are letters. So this one is a letter. This one is a letter of the alphabet. And the last 3 are all digits. Digits, digits, and digits. Now we have to figure out what numbers are going to go into these boxes. Well, just like we have letters, how many letters are there to choose from in the alphabet? If you count them, you have 26 letters to choose from. From A to Z, there are 26 letters. So our second letter, again, we have 26 letters we can choose from. Digits, how many numbers can we use? Using single digits, there are 10. Because you go from 1 to 9, but don't forget that 0, which will be the 10th digit. So we have 10 digits to choose from, and again, 10 digits to choose from. And as you've seen with the fundamental counting principle, wow, I just realized I did that wrong. Y'all did not see that. Wow, undo. All right, but you multiply each of those numbers. So you do 26 times 26 times 10 times 10 times 10, and hopefully you got 676,000. So if you have a 5-character password in which needs 2 letters and 3 digits, there are 676,000 different ways, 1,000 different passwords you could come up with. All right. Now, using that, find the probability of being signed the password MQ836. So out of all of those passwords that can be generated, how many will say MQ836? Well, again, you will write it, probability of MQ836. And we know that probability is what we want over the total outcomes. As we just found out, there are 676,000 outcomes. And out of all those outcomes, only one of them would be MQ836. Only one. So the probability will be 1 out of 676,000. Now, let's step it up just a little bit. Because in this one, they want us to find the probability of a password that does not have an A in it. So it's kind of doing both the last two. Now, first off, we need to find out how many passwords you can make that will not have an A in it. So let's go back to our fundamental counting. That's going to keep bothering me. Counting principle, in which we have 5 different characters, and we know we have 2 letters and 3 digits. Now, you have to remember, we do not want an A. So it was 26, but if you take that A out, we have 25 letters to choose from. Again, 25 letters to choose from because we do not want the A. But we still have 10 digits to do. And we are going to multiply those numbers. And that will give us a total of 625,000. 625,000. So out of all of those are passwords you could come up with, 625,000 of them will not contain the letter A. Now we want the probability that it will not contain an A. So when you do the probability of no A, you have what you have up here, 625,000. We have that many passwords that do not have an A over the total, which again was 676,000. And what you're going to do, hopefully you know, simplify. You can simplify both of these by 1,000 or just by crossing these zeros out, in which you will get 625 over 676 as your probability. Well, ladies and gentlemen, it's been real. It's been cool. Y'all have a nice day.